Welcome. Thank you for joining us this afternoon for the event Harnessing AI to Transform Complex International Supply Chains. So my name is Kashalia Ganatalaka and I'm Head of Partnerships and Community at Boab AI. So just to give you a very quick background into who we are at Boab AI, we're based in Melbourne and we invest and support national and international AI companies. And these are the companies that are ready to expand globally. So we're part of Artesian that some of you might know. So Artesian is known as Australia's most active early stage VC capital firm and was supported by LaunchVic as well. Now, before we do begin, I would like to acknowledge traditional owners of the lands on which this event takes place from, the Wurundjeri people of the Kulin Nation, as well as traditional owners right across our country. I pay my respects to the elders past, present and emerging, and I extend this acknowledgement and respect to the elders from other nations on whose lands we are all joining in from today. Now, one of the fantastic companies that we're supporting at Boab AI is Remi AI. And as you've all seen, we can see that there's a lot of supply chain disruption occurring globally and international complexities as well. So what Remi AI do is that they transform these complexities and they do this by using machine learning. Now, what I want to do is introduce you to Eamon and Alistair, who are partners at Remi AI, and they will run you through how they're working, what Remi AI does. So I'll pass it on to the both of you, Eamon and Alistair.
Yeah, brilliant. Thanks, Cash. Thanks to everyone at Boab and Artesian for putting on this event, and thanks everyone else for being here. So I'll give you a quick intro to who we are and what we do, types of problems we like to solve with some of our customers, and then I'll throw across to Alistair to go through quite a specific use case, one that is front of mind for many businesses in their supply chains in 2021. So as Cash was introducing, Remi is a supply chain technology firm. So we help retailers and manufacturers to bring AI and machine learning into some of their supply chain decisions. So we work across many areas, but all of the work that we do comes from or is centered around a supply chain thesis that we have developed over the last several years. And it's a working title, but we call it the C squared or the 2 C's supply chain thesis. So those 2 C's are collaborative and cognitive. So what we mean by collaborative is that best practice in supply chain is for retailers and manufacturers to work very closely together. So supply chains are inherently uncertain. You have uncertainty on the demand side. You also have uncertainty on the supply side. But by working together, retailers and manufacturers can reduce some of that uncertainty because as a manufacturer, if a retailer is able to give you some indication of what they are planning to do in the future or what they are forecasting for their customers, then that helps to provide some certainty or some certainty on the demand side for a retailer. And by doing that, for the retailer is able to guarantee supply, which, as many businesses are finding in the current climate, is no mean feat. So that's what I mean by collaborative, just facilitating data sharing and retailers and manufacturers working very closely together. On the cognitive side, what we mean is that supply chains are so complex and that they're becoming more so with each passing year. There is so much data that needs to be considered to make good decisions. And for businesses of a certain size, above, say 50 to 100 million in revenues, it's just way too much to do in spreadsheets and Excel, and humans just cannot do the job to the extent that it needs to be done. And so our thesis is that you need a machine learning or an AI approach to do the best work that you can in these areas. And the areas in which we do most of our work are all centered around demand planning, demand forecasting, inventory management and inventory optimization, some price optimization for e-commerce businesses. But the one we're going to be talking about specifically today is all around containers and logistics. So container optimization is the terminology. A couple of final pieces before I hand across to Alistair. One thing we do pride ourselves on at Remi is having a beautiful user interface. It shouldn't be a point of difference in supply chain technology, but it actually is. If anyone on the panel has ever used other supply chain technologies, I should say, they're usually deadly dull and boring, and that was our opinion when we started to build Remi. It's like using an Excel spreadsheet with some extra tabs. So we decided to go the exact opposite way and create something that was what we hope to be a beautiful user experience. We've also coined some terminology within the supply chain called supply chain strain, or that's the working title here, which is a concept that we are developing, and it will become part of our supply chain thesis in the coming months as well as part of the platform. So I'll throw across to Alistair to just detail the problem space that we will be talking about today.
Yeah, thanks heaps, Damon. So yeah, thanks everyone for joining today. Today, just going to be going through some basically the concepts around container optimization and the larger sort of overseas importation optimization that is possible with machine learning platforms at the moment. And sort of just to kick us off, just wanted to for those of you that are not particularly involved in container imports, just give you a little bit of a taste for some of the current challenges that are facing people that whose businesses depend on this. So basically, with the container and importing processes, there are three critical challenges that any business involved in this space face. The first one is around lead times. So the lead times from overseas imports are very significant, and with that you're faced just by default with very significant challenges around your forecast horizon, and you're typically forecasting out over a 4 to 12 month horizon, which means that the forecast accuracy is typically weakening as you go further and further across that horizon. But secondly, these lead times are becoming even more challenging in the current climate because there is so much challenge securing supply. There's so much challenge actually getting onto shipping containers, and a lot of our customers are facing daily challenges trying to literally just book in containers and get that container onto ships, which is dramatically extending lead times and meaning they're having to take pretty significant steps to try and protect themselves with the risk of extended lead times, and secondly protect themselves in having to game the processes, trying to make sure that they can get those containers actually onto ships. The second component that sort of defines this problem space is the overall cost. So right now, especially the shipping costs are at record highs, and it means that the problem space right now is really challenged by the maximizing the profitability to ensure that the actual imports and the containers that our customers are building are in any way actually profitable and they're not losing money, and the import costs are not eating away all the margins of the products they're importing. So that's a huge challenge in this problem space at the moment. And then the third one, which is quite simple, but at the same time is a huge labor cost, is that shipping containers for a lot of our customers, especially across the furniture verticals, are really significant, large real world games of real life Tetris. And a lot of our customers, before they started working with us, are trying to tackle that game of Tetris via Excel, and it's a genuinely time-consuming process where some of the companies, before they started working with us, were seeing a number of full-time staff basically continually trying to build out containers and work out what's a reasonable mix of products per container. And when you throw things like skyrocketing import costs across the containers and challenging lead times, that game of real life Tetris just becomes even worse. So that's the problem space. And just to give you a little bit more context for any of you which are in the blessed position of not actually having to deal with the impact of COVID on your supply chain, some of the impacts that we're seeing across our customers are firstly the significant costs. So you can see in this graph here from over at Bloomberg that the spot rate for 40-foot shipping containers from China to US has just hit all-time highs in the latter parts of this year, sort of averaging just under sort of $2,000 prior to COVID, and now heading upward toward $14,000 per container for a 40-footer. And that is not at this point showing any signs of changing direction. It's definitely looking like it's holding for a little while. And although that's just spot rates for two particular routes, that is something that we're seeing across a huge number of customers across a huge number of shipping lanes. And the second part with that is that, well, that's putting two very major strains on supply chains. The first, obviously, is the profitability of the imports. As I mentioned before, that these costs are destroying, for some of our customers, completely eradicating any margins that they might have on an import. But the other thing that it's also tied to is just there is a fundamental lack of supply. And it means that literally a lot of our customers are facing issues where they book in containers onto container ships, and their bookings are cancelled on the day, or they just find out that the day after, and they basically have to scramble to find the next ship that it can be put on. So right now, it's fundamentally a pretty challenging space to be in, and we've been working quite closely with a lot of our customers to try and help them with the optimization to try and mitigate some of these very extreme impacts during this very unique period. So just for those of you that are potentially more living in the Excel world or not really familiar with the machine learning space or the optimization space, just want to give you a couple of introductory points around what is container optimization, and then I'll go on to talk about some of the use cases. So container optimization is a sort of broad term for taking either a machine learning algorithm or an optimization algorithm and giving that algorithm basically an objective of trying to fill a container in some sort of optimal fashion. And I'll come back to what that means in a sec, but fill it in some sort of optimal fashion, given the objectives that are aligned with your business. And getting the algorithm, this machine learning model or this optimization algorithm, to provide you as a user or as a customer a set of recommended container builds, so that instead of having to use Excel to model out what a container might look like and to add different products to that and to test different quantities, the optimization algorithm does all of the heavy lifting of building the initial container. You give it the initial inputs, but it then basically presents you as the user a recommended container with a series of priorities and an objective that you've defined. And it allows you then to not have to do all of the initial Tetris work where you're trying to build that all of the products in the container. You can just go through, review it, make any tweaks that you wish. You can sort of rebalance it if you disagree with some aspects of it, and then you can just hit approve, and you have purchase orders or orders ready for sending. And what I meant before about objective driven. So a key thing to discuss with the concept of container optimization is that it's not just like a basic optimization black box where you just put in, I want to build a container. You as a user, you go in and you define what are the priorities of your business or your particular distribution channel from a container building perspective. So that can be things like maximizing the profitability margins per container. It can be minimizing stock outs or lost sales at a destination location, like a retail outlet or a distribution center that it's being sent to. It can include things like just maximizing the total volume used of a container, and can also look at things of just filling. Another objective can be filling a container with the only key value items in the filling up of the spare space. And a key point about that is that as a user, you can go in and you can control not only what objectives you care about from that align with your business objectives, but you can actually set the weightings. So a lot of our customers will basically have a blend of different priorities, and then they choose which of those are the most important to them. So a common thing we see is, especially in these current times, it's our customers are going through giving about 70% of the container build, the optimization weighting across to profit maximization, so that you're not losing money per container with the significant shipping costs, but also then putting a decent weighting on filling the container as much as possible, so that during these challenging times, every spare cubic meter is used up. And then finally giving some prioritization to minimizing lost sales at the destination channel or the DC. So that sort of is container optimization in a nutshell. Basically getting a machine learning algorithm to pre-prepare your container builds within the objectives and the constraints you give it, or the rules that you give it, so that you can then just review them rather than having to try and build them in Excel yourself. So to just dive into the definition of container optimization and to talk through a little bit more, what are the use cases? And these 3 use cases are in our platform that are sort of ready out of the box for customers. The first one is quite simple. So if you as a supply planner or a replenishment manager are looking to build a specific container, and you have a set number of SKUs that are sitting in a 3PL or a DC at the point of origin, you can go through and basically just nominate the SKUs that you really care about, that you wish to put in a container, and it will basically take those and build an optimal mix to just try and use up the most of that container space. So it's really, that use case is not that common for us. The second 2 are much more standard across our users, but it is a useful piece when you basically have a set number of products that are sitting at a location, and there is a bit of excess there, and you just want to create a single container. You want to, say, build a 40-footer, and you just want to, instead of having to build it yourself, you just can nominate the SKUs and then ask it to build. The second use case, which is a much more frequent use case in our platform, is where we basically, if you're one of your vendors or many of your vendors, or your 3PL or your DC in the country of origin is providing you with supply across a significant number of products. And as part of that process, you're actually generating purchase orders for these containers at the time of build. Our platform does optimization not just of the singular container, but it actually looks at all of the products. Let's take the vendor example. So it looks at all the products you order from this one supplier, this one vendor, and it looks at those that need to be ordered as of this current order date, and it looks at the mix of those, which of those are stackable and can be stacked upon, and which of those are fragile. Looks at all of their different dimensions and any other sort of mix constraints that you might have, And it firstly finds an optimal number of containers so that you're not over ordering the number of containers. And then, and with that, it is also looking at the mix of container sizes. So usually trying to minimize the number of 20 footers and typically trying to maximize the number of 40 footers to get the most out of each of those shipping events. But trying to find an optimal mix so that you're neither over ordering and but simultaneously you're not under ordering, and you're maintaining profitability across so let's say 5 containers that you might be importing from this one vendor for this order period. And then once it's found the optimal number of containers, it then goes through and does individual container building and optimization by container to get the right SKU mix, the right product mix into each of those containers, so that again, each of the containers is maximizing profitability, maximizing space usage, while simultaneously not doing anything untowards with incorrect stacking or anything of that nature. And this is a very, very, I was saying before, a very, very common use case among our customers. And it basically means that as you as a supply planner or an import manager or replenishment manager, you come in on your given reorder day and you walk into a series of pre-built containers, recommendations by supplier or by DC or whatever other channel by whichever channel you care to break it up by. And with that, you can then review each of the containers, make any small tweaks, and then hit approve, and that can be turned into purchase orders or shipping and building orders. And then the final use case, which is the most complex, but that is when we are doing holistic regional simulation and long-term container allocation. So that is when you don't just have say a single vendor supplying to just a single state in, say, here in Australia, but rather it's for when you're ordering a significant amount of product in from a vendor, but that needs to be distributed across all of the country, across 10 or 20 distribution centers in Australia, across the different states, and then pushed out to a huge number of retail outlets or smaller DCs as a second serving point. And so this final use case, which takes us a little bit longer to set up, but it is basically a long-term forecast process. So we forecast from anywhere between sort of 6 months to 3 years. And we then, on top of that forecast, run a very significant digital twin of your entire supply network in the country of destination of where you're trying to get all the products to. And with that, we basically look at the different possible rates of demand across your long-term horizon, and we start to build out order plans and container plans for that long-term allocation. And with that, you can then see a long-term ordering plan and a manufacturing plan with your vendors and a container distribution plan at a total regional level. And you can basically, as time progresses across that plan, all of the information is updated as the demand changes by store or by DC. That plan updates, and it's a dynamic allocation system that can make changes across your manufacturing and shipping horizons, so that if one state was looking like it was going to have, was looking like it was on a trajectory to have a specific rate of demand, but that's actually proving to be 20% higher as time progresses, then this allocation system and the container optimization can basically adapt as it goes along and start potentially reallocating stock to different areas as it gets ready for shipping once the manufacturing is completed. So that's the third use case, which as I said is a much more complicated piece, but is very, very powerful if you have very complex supply networks and distribution networks across a major region. So just to go back to the sort of, sorry, with all that in mind, just to give you a understanding of our unique value proposition with all of this. So our approach is built upon two key ideas. So the first thing is that we build a digital twin of your supply chain. So we use quite advanced simulation capabilities to sort of build out a wide range of probabilistic modelings of your demand across all of your different locations. And that allows us within that digital twin to also set up outlier events. So if you would like to look at basically scenarios that haven't actually occurred yet, you can use this digital twin to push the boundaries of what's happened in the past, to explore inventory and container policies, to maximize, again, potentially profitability across unique events that haven't actually occurred. And then with this digital twin, we have it integrated with an AI engine. And that AI engine is what houses all of the optimization algorithms and the machine learning algorithms that allow you to build the containers. So basically what we do is with the digital twin, we map out a simulation of your different sales channels, or your different stores, or your e-commerce channels, or your distribution centers. And then we take our AI engine and we integrate it with that, and we use it to build the containers that serve as the recommendations for how you should build your container plans. And that the other point there is it's quite a unique offering, and it enables you not only to do this objective-driven optimization, which I was talking about before, but it also does allow you to do manual scenario testing as well. So if you do wish to just do what-if analysis during challenging times, like during pandemics, it's a very useful environment for that. And the benefits that come out of this are quite significant. So we can see typically like average increased sales and reduction in stockouts. We've delivered huge improvements on margins across container builds as well. We deliver huge improvements across the reduction of manual tasks, so sort of by up to like 70%. So we look at the most challenging and mundane container building tasks within companies' planning processes, and try and get them as close to automated as we possibly can with just a process of review. And one other point to make there is that we give our users significant control over the automation authorization. So you can go in and you as a user can go in and manage what are the rules going into your containers, what are the objectives going into your container optimization, what are the reordering cadences, and any other sort of constraints that you want to set up within your container builds. And that sort of ability to control the automation really does help reduce the manual involvement during the replan cycles. And then finally, I mentioned before, but another benefit which can't be understated is just the ability to do scenario testing, and the ability to simulate and optimize for circumstances that haven't previously been encountered, i.e. like pandemics. And so just to sort of really illustrate this for anyone who's more interested in what's under the hood, but basically we have this digital twin of your supply chain. So when we work with you in onboarding, and we get all of your historical data and your supply networks, the mappings and shipping details and all of that. And we turn that into a digital twin, so a simulation of the way that your supply chain works. And that allows us to basically then train an AI in simulation, so that it's not making decisions in the real world, but rather it can test different approaches to your container builds or to your replenishment decisions in simulation without doing catastrophic financial damage to your supply chain. And then when it's developed optimal approaches to the objectives that you set it, we can then use that or apply it in the real world and use it to give you recommended operational decisions, recommended containers that you can then review and update and approve. And we do actually take everything that you as the user review of the recommendations and then feed that back into the engine as well. So the analogy I like to use here is the closest model that people would understand is the way that Tesla's autopilot works for their the way that their car driving, the AI driving their cars functions. So basically right now in every Tesla around the world, there is an AI engine driving behind the scenes, and it's typically not actually in control of the wheel, but rather it's just pretending it is, and then it's simultaneously monitoring what the human driver is actually doing and looking for the major differences between those two. And when there's really significant differences, it serves as a feedback for the model of, well, maybe that was what the AI was doing was incorrect, or maybe it's what the human driver was doing. And so that's where that sort of that real world feedback process can be leveraged. And that's how the same sort of approach we take to the container optimization. And so just wanted to show you guys a quick sort of screenshot so you can get a flavor of how this actually works. So here's a just simple example in one of our demos of just what it means to just get a set of recommended containers by for your replenishment cycle. So like I was saying, rather than having to come into Excel and try and build your containers by supplier or by destination or country of origin, you instead just come into the platform and you sit down with your coffee and you're given a list of recommended containers by however you'd like to break it up, be it vendor or destination or country of origin. And it means that you can just go through these and review them one by one and just tweak and approve. So yeah, you walk in into the container recommendations and you're given a list of different container builds by destination or by supplier, and then you can click in and view the individual container. So this is just the demo, but you basically are granted a view of all the different products that are recommended to be in this container. You get, we do a lot of customization of this view, but sort of straight out the gate, you get things like your KPIs. So you get the total amount of space used, and you can easily control what's the minimum and maximum space in terms of the cubic meters that you're using per container. You get the estimated freight costs, the total cost of the order, the revenue and margins on that. And then here in this table here, you basically get a breakdown of what are the key value items, the ABC categories. You get a recommended number of units, the total space taken, and in other views, the stackability. And then you get things like an estimate of how many weeks of supply and the current stock position. You get the cost and the revenue of these. But then also, most importantly, you get this SKU priority as well. So the SKU priority is basically to tell you as the user what the AI is thinking. So it's a real explainability function. And it can do things like it can tell you, hey, this product here that I've added to this container, it's important to order this right now, otherwise we're risking stock out. And simultaneously, this is an optimal quantity to order. There's no risk of excess stock or over ordering with this. But so that's the first reason it's been added. You can see that for other SKUs, it'll tell you, hey, this product is it's an optimal time to order it. It needs to be ordered, and otherwise we risk stock out. But the AI has had to fill in, it's had to add extra stock, extra quantity of this particular SKU or particular line in order to fill the container, because there wasn't an optimal mix within the recommended bounds. And so you can quite quickly go through looking at the SKU priority listing and use that to review why the product's been added, and what the quantity, what is the status of the quantity that is added? Is it an optimal amount, or has it had to add extra to fill up space and make it profitable? And you can even set it up so that it can add things like, if it can't build a container, it will add other key value items that don't actually need to be ordered, but are close to needing to be ordered, so that you're just ordering a little bit ahead of time, but you're filling a container and minimizing the risk of excess stock. And then you can go through, you can do a lot around the editing of functions. You can see the system tells you when you're over capacity or under capacity, and you can define what over and under capacity are based on percentages, based on cubic meters, anything that you care about. And you can save those and come back to them the next day, or if you want, you can hit generate purchase order or generate shipping order from there. And so, just give me a sec. Yeah, that sort of closes out this introduction to container optimization, and I'm sort of very interested to see if anyone has any questions.
So just had a question through via the chats. Typically, how long would it take to set up for one of our regular customers out?
Yeah, great question. So it very much depends on the complexity of the use case. So the first two use cases would typically take us anywhere between a month and sort of 6 weeks to establish, and then there'll be a period of training and just general refinement after that. But if it's getting into that complex use case of building sort of a regional long-term simulation of your entire distribution center, that's more like a sort of a 4-month implementation process. But a lot of the time we're doing the first two to get started, and then moving on to that third use case as a next stage during onboarding.
Yeah, very cool. And does this process work pretty well hand in hand with the traditional replenishment operation? That is, a traditional replenishment operation at a store level, whereas this is at a DC level, or they quite distinct in the businesses that we work with, or how does it all work together?
Yeah, so yeah, another very important question. So that is very much customer dependent, and the system is very flexible in that manner. So we have some customers who are doing container optimization at the point of vendor order. So basically every PO they raise with one of their suppliers is a specific container. And we have other customers who are, their suppliers are shipping all to 3PLs or distribution centers sitting at the country of origin, sitting in the country of origin. And with that, they're basically sometimes taking a mix of products from different suppliers and bringing that over to DCs. And then at the destination end of side of things, we see some of our customers, these containers are typically going to the DC in the destination country, but sometimes even that is just going straight to store in very, very rare circumstances. And so our system is designed to be able to sort of deal with all of those use cases. So if you're in a situation where you're ordering with a vendor, and then and that's with your supply planning team, and then you have a logistics team that manages the product as it gets shipped from a DC that you manage in the country of origin, and then bringing it into a DC here, in the destination country. And then you also have a replenishment team that are managing the individual allocations by store or channel. We can deal with that circumstance where we're just doing container optimization middle section, and we can also provide recommendations for the ordering to your supply planning team, and replenishment allocation recommendations via our optimization engine to the store and sales channels.
Yeah, fantastic. Very cool. We've had another question through via the chat. So we mentioned the work that we've done with the furniture industry. Are there any other sectors in which it works, where it works very well?
Yeah, so we're doing this across a range of different verticals. We're working with customers that are in furniture space, working with customers that are doing this sort of just within like homewares and all sorts of things like bins and additional home storage, working with customers that are doing this across material supply. So I think that things like automotive components and things like that. So right now, this system works incredibly well across all of those. It's just wherever there is a challenge or a problem space of cost optimization, and a challenge around optimizing the quantities that you're getting in, and the challenge of trying to move away from Excel, this system applies, and is an extremely affordable system as well, given the the complexity of what's under the hood.
Yeah, fantastic. Couple of other questions are flowing through. In terms of the ideal size of the business that this, where this could work best, the businesses that spring to mind are ones that are filling containers themselves. They don't have to worry about fitting in with other businesses. So there must be a floor, I suppose, below which it doesn't make complete sense for businesses to be using this. Where have we seen this work best in terms of the size of the business?
Yeah, sure. So rather than talk about sort of business revenue or import ordering, the simplest thresholds that I like to think about here is just if you're bringing in containers that are entirely your own, and you have someone who's dedicating more than sort of 20% FTE to building those containers, and it's typically being done in Excel, then there is an ROI argument for this sort of a system, and as that builds out, that gets more and more, the ROI increases and increases. So that's the simplest way that I like to think about it, is because it's such a brilliant system, such a brilliant platform for reducing all of that manual labor. Even if you ignore ROI on the margin improvements by container, it's that's the simplest explanation for, the simplest threshold for knowing that your business is ready for such an AI engine.
Yeah, fantastic. We've just got one more question here. So Simon's just asking that there are supply chain pressures all over the world. Post-pandemic, how has your AI assisted in managing those unique circumstances? So sorry, Simon, I'm not sure if you're asking about how will we be helping in the post-pandemic supply chain world, or if you're asking how it helps in the current state. So maybe we could talk about both. So Al, maybe starting with current state. What have we done with customers in the pandemic world?
Yeah, sure. So maybe just to start off, like in the early stages of the pandemic, we did a huge amount working with key customers around bringing in additional data points to help them with their digital twin and modeling of their forecasting. So we had huge projects with a number of sort of Fortune 100 and also health responses as well, taking in data around government shutdowns, taking in data around mobility. So looking at the changes that lockdown was generating around the way people were moving around the state, and using that across a retail perspective. And that those initial responses were all about supporting forecast improvements through very significant, very unprecedented complexities. So trying to not only just provide better forecasting across the buying behavior, but also forecasting the changes around states and regions moving out of lockdown and buying demand potentially picking back up. And then after that, we moved across into a period where a lot of our focus became around the optimization against the unusual risks. So once we finished off those initial projects where we were bringing in additional COVID-oriented data, moved on to looking at, once we had basically a handle on some of the buying behaviors and customer behaviors and supply behaviors that were starting to emerge out of the pandemic times, we were then moving into, well, how do we optimize to minimize risk? So we were using probability systems to generate a breadth of possible options of what might occur across supply risks and across demand risks, and then trying to find optimal decisions and routes through those. So that could be simple things like we would work with customers across their container optimization to map out what happens if lead times are stretched by 40%. What are my replenishment decisions right now in the chance of that risk, and allowing customers to do scenario testing there. And now, as we're entering this new phase, the main areas that we're focused on are probably twofold. The first is a number of our customers are seeing exceptional pricing and supply challenges across raw materials. So we've been doing a huge amount bringing in price indexes across raw materials and doing a whole lot of predictive modeling to help them understand where their supply costs may be heading over that sort of original supply horizon. And the second thing we're doing is a huge amount of optimization given the supply risks. So that is very much focused on like container optimization, major supply planning, and trying to put in the longest possible lead time horizons so that we're maintaining supply and maintaining alternate routes of supply, while simultaneously trying to minimize the chance that our customers are going to end up with significant excess stock as this dies off. And the final point there is one of the challenges that we're working with a lot of our customers on is doing a lot of modeling on the backlog of demand. So working with customers that have, because of such significant supply shortages due to raw material challenges and container challenges, there's a backlog of demand, and trying to map out what is the curve as that backlog is actually met. The backlog of demand is actually met. So that's our current state focus in this current pandemic state.
Yeah, very good. Very good. Lots on, that's for sure. One final question just before we finish up. In terms of the integration process, so for everyone on the call, most of the work that we do, or all the work that we do, I should say, requires data from customers in some way. And so there's usually an integration process. So we have to pull product information, inventory levels, historical sales, things like that out of customer systems. And so this question is talking to how difficult is that process? How difficult are most of the integrations that we need to do when we onboard a customer?
Yeah, so we have very standardized integration models to talk to all of the major ERPs. And so if you're using any of the standard approaches like SAP and Nav, Dynamics, Fishbowl, NetSuite, any of those, we basically just have standardized integrations which are very quick for us, that allow us to sort of tap in, a pro forma methodology and we can makes for a great starting point. And then we do find for some businesses there are a range of auxiliary data sources outside of their ERP. So that can be things like shipping details or lead times that are more often than not managed via Excel or a data lake, a data warehouse. And so we do, let's say about 60-70% of the time, we're integrating with an ERP and then potentially picking up some auxiliary data sources. And that can even be things for our forecast modeling, things like the integration with the web traffic or Google Analytics, or integrating with Amazon Seller Central, or anything that might, anywhere that there might be interesting demand signals that we can leverage in our modeling or in our forecasting. So yeah, that's a pretty typical integration process would just look like we do a template integration with an ERP, and then we might pick up some auxiliary integrations with some external data sources, be that Excel, be that a database, be that Google Analytics or Amazon Seller or Channel Advisor, anything of that nature. So yeah, that's sort of our integration process.
Yeah, fantastic. Well, it's pretty much on time. So yeah, Cash, I'll hand it back to you.
Awesome. No, that was really great. So just wanted to say thank you everyone for joining. Eamon and Alistair, what would be the best way to get in touch with you guys?
Yeah, you can email Alistair or myself directly. I'm ebarrett@remi.ai or ahamilton@remi.ai. Otherwise, we're both reasonably active on LinkedIn or via our website. So yeah, find us anywhere.
Yeah, awesome. And also you'll get an email after post event as well. So we'll include all those details, and feel free to email me via that as well if you'd like to connect with the guys, and I can put you in touch with them. So fantastic. Thank you everyone for joining. Really appreciate it. Thanks, Eamon and Alistair. Have a great afternoon.
Thanks for your time, everyone.
Thanks, everyone.
See ya.